All right. Hello, everybody, and welcome to this year's Flame Game Jam, and that we have combined with FlameCon number 7. So, we will start this stream by talking a bit about the Game Jam, so that people that want to get started directly, or if you're in a weird time zone, you can go to bed after you get to know the theme, etc. Oh, wait a second. Wait 2 seconds. We have a little bit of technical issues here. There we go. I had myself in another YouTube tab, so I heard myself saying exactly the same thing like a few seconds afterwards. Now it should be fine though. So let's get on with the slides. So Flutter and Friends is our main sponsor for this Game Jam and the FlameCon. And if you don't know what Flutter and Friends is, it's a Flutter conference in Stockholm from the last of August to the 2nd of September. And it's usually a lot of fun. It's not like any other conference. Like there's lots of social activities and just a lot more fun things than just the normal conference stuff. And then we also obviously have a lot of cool speakers and workshops. And if you want to get some tickets, you can use the discount code there, which is community. You will get 10% off or something. And I think this year actually the whole Flame team will be there. So yeah, you don't want to miss out on that. And for our second sponsor, it is Danger World, and I actually have the creator of Danger World here that can present it. Welcome.
Hello, everyone.
And thanks for sponsoring us. I'll give you the stage, and you can tell us a bit about the Danger World.
Thank you for having me. My name is Anthony Tarmina, and like Lucas said, I'm the creator of Danger World. Danger World is made entirely in Flame, and Flame is what makes it possible for me to make a game that's this complex within a year. And we're going to be hitting Steam, the Apple App Store, and Google Play Store here later this year. And thank you, Bluefire, for hosting this jam and for making Flame so easy to make games in. And I'm really excited to see what everyone here makes for this game jam. I'm super excited to see what you all make. And you can take it away, Lucas.
Yeah, I was trying to find a button to bring myself back.
No problem.
Thanks a lot. I'm really excited to see what comes out of this when you publish it.
Thanks.
Yeah, see you later. Have a good one. All right, so on to the important rules that we have for the Game Jam. So for the Game Jam, you can join in as a team, but you can only join a single team. And on itch, there is not really a team concept. So when you're submitting the game, it's only one person that submits the game, and you write all of the other participants' names in the submission. And of course, all of the work for the game development must be done within the given jam period, which is from today until next Sunday. So not this Sunday, but the one on the 27th. And yeah, obviously, if you already have started with a game that you continue with now, that you will be disqualified. And for assets for a game, you can use any assets made by you or your team, or anything that is like free or legally purchased, and their license allow them to be used in open source projects. And it's always nice to credit them in game, and sometimes you even need to form the license. It's allowed to use AI generated assets as long as the model only has been trained on free and open assets. So for rules, for packages, you can use any packages you want, but you need to use the latest Flame version. And that is because one of the reasons we have these game jams, it is because we want feedback on Flame, of course. And if you're using an old version, maybe you will bump into bugs that we have already solved, or bugs that we haven't introduced yet. And all entries must be open source so that we can check the code, and the submissions must include a link to the game source code. And it should, of course, be like friendly content. No extreme, not suitable for work, sexual content, or excessive and extreme use of gore and violence. And obviously, no hateful content, like don't be a douchebag. And if you're unsure, which you probably wouldn't be, you can read our code of conduct. It is pretty clear what you can and can't do. Just be a nice person and you won't have any problems. So for this year's Game Jam, we are 4 judges, I think. It's myself, and it's Luan, and it's Renan, and it's Erick. And that, so we have a 5th member in Bluefire called Devkage. I have just learned that it's pronounced. I've always pronounced it Devcage. And he had one, when we asked him to join Bluefire, he said, oh yeah, I'll join on one condition, and that was that he could still participate in the game jams. So Devkage will actually be participating in the game jam too, as a solo team. And we will be judging the games in 4 different criteria. We have like the graphics, how good the game looks visually, and like it can be any type of style as long as it's appealing and consistent across the game. And all of the categories can get, I think, 1 to 3 or 1 to 5. I don't remember. You can see that on itch.io. And then you get like a combined score in the end. And then we have audio, and that is like how good the game sounds, both in sound effects and music. And if you make the sound yourself, you can see more comprehensive version of the rules on itch.io too. But if you make the audio and graphics yourself, you have a chance of getting higher points. You are capped at 3, I think, if you don't make the graphics and audio yourself. But that is still fine. You can still win by doing that. And then we have the game design, how well the game mechanics work and how good the gameplay is. And like, are the controls good and easy to understand? Are the rules of the games clear? And of course, most importantly, and almost always one of the hardest things, is the game fun. If you manage to make a fun game, that is extra points. And then we have the theme. And so soon you will get to know the theme for this year. And then we will judge it, like how well can the theme be identified and have it been used in a clever way. And like, it's important to mention that the theme doesn't need to be interpreted literally. You can have any creative interpretation as you want. Just make sure that we understand your creative interpretation, but we probably will. We will look for it. And now on to the most exciting thing for the evening, or I would think so, at least if I was on gonna make the game, what the theme will be. So drum roll. This year's theme for Flame Game Jam, or Flame Jam 2025, I guess we call it in itch, is the Space Race. So the Space Race is the theme for this year. And remember, you can interpret it however you want. It doesn't have to be the first interpretation that comes to mind. You can definitely come up with lots of interpretations on this. So I'm very curious to see what interpretations you all come up with. And for this year, we have something called diversifiers. So you have to choose one of these diversifiers, and there will be 3 of them presented to you now. So you can choose from either using shaders somehow, or you can have immersive sounds in your game. Or what about a branching storyline? So you choose one of these. You can, of course, you can use multiple of them in your game, but make sure to specify which one of them that you have chosen in your submission so that we know which one we should look for. And with that, we can go over to the FlameCon stuff. So this was me, Lukas Klingsbo, or Spydon online, and I did the opening of the stream and announcing the FlameJam 2025, as you have already seen. And next up is Luan, the initial creator of, or the original creator of Flame. And he will talk about what's new in Flame in the last few versions since last time we had the FlameCon, I think. And after that, Erick will talk about a package that he have built called Flame Console, which helps you at like debugging your games in runtime, which is really cool. And after that, Renan will introduce the new shader API for Flame that we released just a few hours ago. So that's very exciting. And then we'll have Jonah Williams from Google. He's actually the top one contributor to Flutter. If you look at, I think, both lines of code and commits, that's pretty impressive. And he will give us a quick look at Impeller performance for 2D games. And we'll have a quick Q&A with him too. Oh, we'll have a quick Q&A with everybody. So ask your questions in YouTube and we'll bring them up here. And in the end, we'll bring the whole Flame team on and you can ask us any Flame questions that you want. And that's it for me. So now I will bring on Luan on stage. Now we will just... Hello, Luan. Welcome.
Hello, Spido.
Let me see if I can find your slides here. Or didn't you have slides? Yeah, you had slides.
I do. Do you want me to share or do you want to share your slides?
Yeah, you share them and then I put them on here.
Okay. Allow. Share this window.
So I can tell you that as usual, we have a physical Flame game jam here in my apartment. So there are a lot of people sitting out there starting to code.
Nice.
Yeah, always fun. It's too bad you live in Canada, otherwise you would have very well.
Yeah, I always wanted to go to your physical game jams.
Yeah, we should have it sometime close to the Flutter and Friends so we can combine it. Exactly. Okay, let me try to find your slides. Here we go. And I will go out of screen. And yeah, enjoy the Flame news by Luan.
Okay, so thank you everyone for joining. It's always nice to see how many people are, joining and interested in Flame, both in FlameCon and also the FlameJam, which I like so dearly. And as usual, I'll be talking about a little bit about Flame news, just some interesting things that have been coming out that not everyone might have seen. I will preface this by saying that it's been a while since we've done this. So this time I'll do it a little bit differently. I'm not going to do an exhaustive list of literally everything that was added because it's just so much since the last time. We've had literally countless, bug fixes, upgrades, new APIs, new helpers, documentation, tests, and most of the things are the most important things, which are the small things, but are also the things that, are just there and just work and you don't really see it that much. So I'm not going to be able to focus on all of those. But instead, what I'm going to do is I focus on a more recent time frame than since last FlameCon and just picked up like some big interesting things. And I'll describe in a bit what those are going to be. But just in general, I wanted to call out that most of these contributions, all of these contributions come from our community, either us here or, the people on Discord, the people who contributed PRs, like everyone here using Flame. and that's what makes it great, I think. So it's always so lovely to see everyone contributing. So without further ado, I'm gonna try to be quick this time. I know I often go over time with these things. So I've categorized in three categories the things I'm gonna talk about. In the first one is gonna be under the hood. So normally I'll leave this last because for me this is like the most interesting, but I suspect for most people this is not the most interesting. These are things that you might not actually see at all. And in fact, if they work well, you might not even know that they exist. But I think they are, at least the ones that I pick here, they're interesting to know about, and they might be relevant in the sense that, you never know what you don't know. Just having heard these things, if something happens, you kind of have the right idea, you know where to go, even if you don't know the full details. So this is the first category. So let's see a few changes that qualify in under the hood. So the first one that I wanted to highlight is that we have a brand new order set version. This is a big departure actually from the previous versions. But let's step back a little bit. If you don't know what order set is, basically the way Flame works, we have this component tree hierarchy, right? And the way we implement that is by using this library that we also wrote called ordered set. And what it is, it's, as the name says, it's a set that has an order, right? So it basically it's a list where we put all your components, but instead of being in insertion order like a normal list, they are automatically, upon insertion, ordered by a certain criteria. And that means every tick, when we iterate over your components, we can iterate in order in O of n. So we're not paying any extra cost to iterate. And the trade-off is that we pay a little bit of cost in order to insert or remove components. And the way we do that is we use this library called order set, which underneath uses a splay tree set from Dart with some modifications. And it has been known in the community that we've had some issues with concurrency with this structure. And the main issue there is because when we iterate your components every tick, we don't want to materialize a copy of that list. So we use an iterator, which is very fast. But if you know iterators, you know that the source list cannot be modified. The source collection cannot be modified while iterating. And you might think, well, why is it being modified? Well, anything that you do to you either adding, removing components to the tree, you are modifying the sets. And you might be doing that during update calls, which are while it's being iterated, or you might be doing this in async contexts. So if you have timers, or if you have user input that are handled, immediately when it happens in parallel with the game loop, those modifications can happen. Now, we've solved this in the past. It's been so for a while for most operations that you can do with components. For example, if you add or remove components, what happens is it's not immediately added. It's saved to a queue to be processed later. And then it's all processed in between game loops. So operations such as add, remove, or even move, or that is reparent or change the parents of a component, these are all done that way. But we had one operation that had a problem, which is changing the priority. So the priority is the thing that we're using to sort these ordered sets. And basically it means that a component with a lower priority comes first. So it's rendered on top, it's processed first. It's rendered on the bottom. And the problem here is when you change the priority of a component, that's an immediate operation that then alters the sets. And so what did we do to kind of fix this? We've been over a few ideas, but the one that we decided in the end is is that we basically made a new version of the ordered set. And this new version, which you can see here, is called the mapping ordered set. It uses a slightly different implementation where these priorities are cached. So whenever you insert things, the priorities are kind of set in stone. And then when you change the priorities during the game loop, you are allowed to do that. And when you get priorities, they will be updated, but the order of the set will be set in stone until the end of that tick. And for the next tick, we do an operation called rebalancing, which is if we need to, we will basically reorder the set based on new priorities. Again, this is only relevant if you have elements that are changing priority during a game tick. And this should all just work under the hood as well. So I've added this callouts for me. Like, what does it mean for me? Well, hopefully nothing. It doesn't mean a lot for you. It should just work. We did change some classes, as you can see on the right here. So if you are using ordered set directly, you might need to change some imports and change some names. But it all should just work as it should be right now. But if you see any issues regarding priority, you know that it's probably related to this, and you should let us know so we can investigate. So this is the first change. Another under the hood, very interesting change is that we finally migrated from 64 to 32-bit math. So a little bit of backstory here. Flame uses this library called vector math, which is a very well-known library in Flutter that a lot of stuff use, including Flutter itself, uses it as well. And it provides a very basic constructs such as vectors, matrices, mathematical stuff that you're definitely going to need to make a game. And in fact, the curiosity here is that in the very first versions of game, I had a class called position because I realized that Flutter had this like 3 or 4 different classes that all kind of represent the same like pair of numbers. And I wanted like an easy way, so I created one, and it had all the vector operations. And then I realized, oh wait, this already exists. We'll just use the vector math library. So we've been using this for a while, but we've always used the 64 bits version of the library. Basically, this library has 2 versions, same library, same names of stuff. So the class is called vector2, but there's 2 implementations of it. And that's fine for the library. It basically allows the user to decide what they're going to use, right? If they want the 32-bit precision or the 64-bit precision. The problem is a lot of things use 32 bits. Flutter now mostly uses 32 bits. So Flutter has been in this back and forth. It has used 64 bits for stuff in the past. So that's where the whole confusion comes from. But newer APIs have become available in Flutter, such as the shaders API that is now integrated with Flame. We're going to talk about it later. And the Flame 3D and GPU stuff all used 32 bits. So it is kind of jarring when you have to import both versions of Vector2 and convert one to the other. And not only that, it's could be a performance hit if you need to do this conversion like every tick. So ideally, we should all unify, and that's basically what we did. Firstly, we migrated Force 2D, which is the physics library that has been already ported out to 32. But notably, Flame was still using all the 64, and then we recently made a switch. Big thank you to Renan and Zias, I think. They've been working on this relentlessly. This is a massive change under the hood that required touching a lot of files. A very impressive project. But it's going to make life so much easier. And what is in it for me? Again, hopefully this should all just work for you. The one main thing is that imports, again, might be wrong. So if you're importing the 64 version of Vector and stuff, you might need to import the 32. If for some reason you do need both, you can import both. You're just going to have to rename one of them. But if you have anything using 64, do let us know, because the goal is that basically you don't have to care. Everything uses 32. The other thing you might be thinking, oh, are we going to lose precision, right? Because now we have less bits. And yes, it's of course less precise, but we have come to realize that we don't really need 64 bits for basically anything. So again, your game should still behave the same. If you identify any rounding error, especially, it could be some sort of compounding error that aggregates over several ticks. If you identify something like that, let us know, because it definitely could be related to this change. But again, this should all be under the hood for you. And then the final under the hood change that we made is we added the render context API. So this is a brand new API, and it's kind of an infrastructure thing, so I don't expect necessarily people to use this directly in their games, though I'm open to the possibility and eager to hear if people find this useful. What it is basically a way to pass down any information related to rendering to indirect children. So basically, it's a different way. Instead of you checking your parents and figure out like your closest parent, basically you create a class that extends the render context, and you can store any sort of information there. And then at some level in the hierarchy tree, some parent provides that render context. And then on your child, you can find render context, and what it's going to do is going to iterate over the hierarchy and find the closest parent that provides that context. So this is very similar to like prop dealing or something like that in like React or other libraries, except it's implemented in a more performant way, so it's not actually iterating the hierarchy. You just store these things in a stack. But again, this is more of an infrastructural thing, and the reason we implemented this is to support two features that we want to have and that are much more directly applicable. The first one is the camera, which we now have this possibility of having multiple cameras. It's been there for a while. The way it's implemented is not as clear cut. There's some, I wouldn't even say hacks, but some nuances on the way it's implemented that could be simplified vastly using this. So that's one of the goals. But really the main goal is a brand new API that Renan is going to talk about it later. He has been working relentlessly on this, and it's super exciting. Like you're going to see, it's jaw-dropping how beautiful it is, which is of course the shaders API. And shaders indeed happen to be something where you have a parent and you want the children to know about the parents, the thing from this parent that provides the shader. So it's the kind of the perfect way to implement it. And that's it for the under the hood changes. Now our second category is component pieces. So this is basically new components that are being added, or parts of components that are much more directly applicable. So this is things I actually expect people to use directly, and I think they're super exciting. So let's go over them. The first one here is the function effect. So if you're familiar with our effects sub library, it's a way to modify components, and we provide loads of different effects such as move, rotate effects, color effects, and they all do specific things, and they are very composable. But then we came up with this idea, and I remember sorry, I remember this being said on our chats. Something I might be paraphrasing, but something along the lines. So it's a good idea that I'm not sure how we never had it before. This is just a completely arbitrary function. You're just taking the target, which is the component, and the progress, which is a number between 0 and 1, and you just do your own thing. So it makes it very, very easy to not need to create new effects, but basically be able to compose existing ones in basically any way you like. So it's highly composable. In this one, we have to thank Spydon for implementing. So here in the example, we're basically mapping this progress to just an enum, player state. And I'm sure, the player component here cares about this current player state and render something different. But you can see basically, until 50%, it's yawn. And then after, a certain point becomes idle. So very simple to use, but very, very powerful. If you're using effects, you're probably going to find this very useful. We also have some brand new layout components. So there's always been this dichotomy with Flame about building UIs, where, ideally, if you're building something that looks more like an app within Flame, you can always use Flutter. And Flutter has all these nice tools like rows and columns, right? But sometimes you're building something that's not quite a UI, but you still want to lay out components in a certain way, right? So maybe, you want to have, your heart containers and they're in a row, or something that it's a column, but they're all Flame components. So we've had the align component before, which is very similar to the align class in Flutter that you're familiar with. But now we've added two more, row and column. So now that's going to make it even easier to basically lay out your components. If you have multiple components that you want to display in a certain way, of course, you could do this before, just iterating and setting the positions. But this is just going to do it for you. And again, we have Live10 on to thank for this change. Another new component thing that we have that I'm really excited about this one is I have been working on adding more options to our text rendering pipeline for a while, but eventually I have been adding this like, oh, let's add code and strike through to our markdown parser, so I could have more styles to play with, but I found myself too limited to only having 4 or 5 different ways to format text. So I looked up some custom markdown extensions, and I found this really neat one where you basically add, with braces, a class name to your block of markdown, and that allows you to have unlimited styling options instead of only those. So you can see in the example here, our classic Fire and Ice poem that we use for the Flame Markdown. It has the custom, the standard, formatting for like bold and italics and strike through. But in the very end, we want to create a custom format. We'll just call it, alter class name, and you can have as many as you want. So if you want to have, a text rendered in your application, you want to have several different styles or different things, like you want the character name to have a background, for example, or you want, have different font sizes for different things. You can use this to very easily render text to basically any styling that you want. So this is really exciting as well. And just in general, in this area of new components and new things for components, there's just so much. So I started to go through the actual changelog, and it's just insane. There's too many things to even talk about. Sorry, I put some here on the list. I also wanted to call out some people doing great work in our other libraries as well that are tangent to Flame, such as audio players and gamepads. Gus L22 and Mark Vidion have been working relentlessly on those as well, which are very important for the ecosystem. There's, you cannot just have Flame. You need every other package to combine and form something great. I just wanted to call out on this slide that if you want to go through the PRs page on Flame, the merge tab on the PRs and the repo, and just skim through, there's so many like neat things that sometimes it's just a one-line change, but it's so helpful. It just inspires you, if you ever want to contribute and send something as well. I think that's what is so great about it. Okay. Final category, developer toys. So these are things kind of adjacent to Flame that help you to make your game. So they're very, they're not exactly, within the library, but they are interesting to know, and they might be helpful for the jam itself. So I have 3 things on this category. The first one is kind of still work in progress. So I was starting to work on these benchmarks for Flame as a request from Spidon. So I made this library called Dart Benchmark Action. Basically, it's just going to run benchmarks for you and compare, the main with your current branch. This is based on a benchmarks folder and structure based on the package benchmark harness. So it's pretty standard stuff. It's just a GitHub action that does it for you. I have added to other side in Flame, and it's working well. There are a few problems with it. The main problem is that basically it's running arbitrary code, so we haven't have a good way yet to sandbox it, which means this only runs for contributors. So if you that's not a contributor make a PR, it's not going to run, because we would basically be running a random code that someone posts on the internet, right? In the privileged context of the repo. So we need some work yet to make it sandboxed and basically make sure it can run in like a safe environment. The other things that I think the actual benchmarks, so the library is working, but the actual benchmarks that we have for Flame, I don't think they're super good. I feel they could be improved. So if anyone is interested on this, it's an active area to evolve. Next developer tool is the Flame DevTools. So let me play the video, and the video says more than 1,000 words. And of course, Erick's gonna have a talk in a bit explaining all about this. So this is a neat way of
No, it's perfect. I mean, we have plenty of time today, so you can
Cool.
take as long as you want. So if anyone has any questions to Luan, just shout them out in the chat and we'll bring them up on the screen like this. But with your name and with some useful content.
Hello. Hello, Renan.
And yeah, some things we can inform you of meanwhile. Eric is not going to talk about the DevTools extension that Luan was talking about. He's going to talk about a package called Flame Console, which is another type of utility that you can use for debugging.
Okay, I completely mixed those up. That's my bad.
Yeah,
but
understandable.
I suppose you could use both, right? Are
Yeah.
they like complementary?
Absolutely.
Yeah, there you go.
Absolutely. And what more? Yeah, if you haven't joined our Discord, I can really recommend you to do that. We have a Flame Game Jam channel in there too, and that's where all the action is going to happen during this week. So I will post a link for the Discord here in a second. There we go. And what more did I have? Yeah, if you have a GitHub account, which I hope most of you have, go in and give us a star on GitHub, because we have like 9,950 stars or something like that. We're so close to 10,000.
I was just looking at the other day. And I thought, oh, maybe we can get to 10K.
Yeah, exactly. That would be really cool. We have a question here, actually.
Nice.
Do you guys have other long-term functionality / features goals?
I don't think we have like any like major specific new things. We do have a issue on GitHub. Let's call Flame V2, which is basically all the things that we deem that are like too big of a breaking change to do right now, and we're kind of collecting so that when we decide to bite the bullet and do the V2, that's where we're kind of starting them. But anything that's incremental or that's backwards compatible, we obviously don't need to wait for Flame 2. So I don't know if you have anything, Spider, that like it's on your mind as like a future thing, but
I don't know. You're doing quite a lot of work on the 3D stuff. I guess that's some long-term functionality and feature.
Which I mentioned here.
Yeah, exactly. But yeah, great question. And if you guys have anything that you think we should focus on, don't be shy.
Let us know.
Let us know.
I think it's very much based on like, we're all like doing this because we like to. So if you want to contribute with a new feature, like you're more than welcome, and everyone is more than welcome, and together we can build great things.
Yeah, for sure. Sayos was talking here about latency, and I just thought I'd mention that in the current version of Flutter, there is quite a big bug for rendering assets. So if you're experiencing like frame drops on the current version of Flutter, they will be fixed on the next version. It is already fixed on main, but it will be a release in May where it comes out too. I know that Grayson have definitely experienced that. He's stuck on an old Flutter version due to that. We
also just added the benchmarks, which again they're not super good right now. I mean, the runner works, but we need better benchmarks. So if that's something you're interested in contributing, creating new benchmark scenarios, which are basically like a test file that just do a lot of stuff. For Flame or for the libraries you use, that would be super helpful as well.
Yeah, I wonder if we could actually have caught that bug in the benchmark, because it is like a render thing, right? And I'm not sure if that would be represented correctly in a headless environment.
I think we test kind of our end of the render pipeline, but not the actual like canvas implementation, because we're not actually rendering.
Yeah, exactly. We got another question here. Apart from Linux missing support, how is the status for other platforms? Do you think it is something we can play with soon?
So 3D. Definitely, like you can play with right now. That's the first thing I'll say. The status, I'll say it's slowly emerging. It's not a mature, established thing, both on our end and on Flutter's end. Mainly, I've been using it on macOS. It works really well on macOS. I know that it should work on Android and iOS, but I haven't tried it on those platforms. and I know it doesn't work right now, even though it should on Linux and Windows. Actually, Windows I haven't tried. I don't know. I heard it doesn't work, but it definitely doesn't work on Linux. So if you are willing to do it on Mac OS, it definitely already works. Like you can play around with it, and we have the basic structures for like loading a model, putting it on screen, animating, moving around, creating meshes, creating surfaces. The very camera, lighting, the very basics we kind of have set, but I would consider everything to be experimental at this point. So it's more like if you want to be an early adopter and play around with it, you can definitely start doing things. There's even some example games that I made just to kind of showcase, which is the donuts game, collect the donut and defend the donuts. So yeah, this is like an emerging area. If you're interested, we would love to have more people participating, as long as you're, with the understanding that this is like a early steps, experimental, things might break, etc.
Yeah, so definitely check that out. If there are no more questions for Luan, then it is time for Erick to talk about testing at runtime with Flame Console. Thank you, Luan, for
Thank you, Spido.
update. And let's see here. Here we have Erick's slides. And here we have Erick. Welcome, Erick.
Hello, everybody. Hello, Lucas.
I guess I'll just leave the stage for you. You can handle this.
Awesome. Yeah, sounds good. So, hello, everybody. I'm glad to be here on this 7th edition of FlameCon. Today, I'm going to talk about something I think is interesting. Is a way it's not going to solve all your runtime testing problems, but I guess it's a great help. And me being a fan of terminals and consoles as a thing, like I think this is very cool. So I hope you all enjoy. So before I get to it, a really quick introduction for those who does not know me. I'm Erick. I live in Brazil. I work at Very Good Ventures and I'm part of the Flame team for a long time now. And yeah, real quick about me. So what we're going to talk about here. So like I mentioned, we're going to talk about consoles, terminals, and I guess a more known term about this is like developer console. I'm pretty sure all programmers saw that either on Chrome or on browser. We have those developer consoles. On Flutter has the dev tools, which is kind of more or less like a dev console. So what is the idea, right? So like being a console, being a terminal, it's a tool or it's something that allows developers to run commands and while the game is running in order for you to be able to test and simulate specific conditions. So I guess the key here is runtime. So like we are able to interact with your game, with our program, while it is running. So while the state is there, so you are able to do things that could be difficult to do by just mocking a state. So I hope I will be able to show that live, and it will be more clear. And also, I would like to mention that this is not something new or something that we are inventing. Many games throughout history has something like that. For me, this was the first time I encountered a developer console in a game. It was in Counter-Strike. Was not these images for the Global Offensive, the new Counter-Strike. My first interaction was the good old Counter-Strike 1.5, but I didn't find any cool images about the console. But anyhow, Counter-Strike has that, and you are able to pull the developer console, and you can do a lot of interactions, like you can add a bot, you can enter God mode, so you are invincible. If you want to test a specific weapon and you don't want to go to the whole flow of buying or whatever, picking on the ground, you can just take command give and pass an ID for the weapon. Your character will get that weapon. So and this is the magic of a console, right? You can interact and modify the state on runtime real quick and easy. And then, like everything on Flame, like most things on Flame, I guess everything, safe to say that everything on Flame, it's very modular, right? So you don't, it's not something that comes out of the box, but we have a package for that. So you don't need to have that code in your game if you're not using, but if you want to use it, just add a package. So for you to start using Flame Console today, you just need to add the Flame_console package to your pub spec, and then you'll be able to do all the good things that it gives you. And what Flame Console comes out of the box, right? So there are a bunch of things on Flame that are common to all games, right? So mostly, I would say 98% of the games we use the Flame component system in a way, so you can list those components with a simple command, with a simple ls command, which I'll show you live next. You can enable, disable debug components on debug mode on components. If you ever use that, you remember that it will outline the component, show the position, and some information like that. You can also remove a component from your game for some reason that you want to test, I don't know. You can specifically like pause or resume your engine. And the coolest thing, which I also try to show you today, is how you can write your own command, because each game has their own quirks and their own specific logic. So you definitely will want to write like specific commands for your game. And then now let's show how this works in practice. So I'm gonna try to do a little live coding, little live presentation. So we all know how these things go, so bear with me while I made that work. Let me pull up my code screen real quick. There you go. Lucas, if you can add my screen to the stream, I would appreciate. Awesome. So let me put a quick zoom. So first of all, let me present a little bit of the game that I'm working on, which has Flame Console and which I'm gonna use as a demonstration on how to use. It's a very simple game. It's very early in development, but hopefully it will be an interesting place to show. So first thing I want to show is like how the console looks and a basic of the few commands. So I just pulled the console down here. You see, I really try to make this look like a real console. You have like our output screen here, and then somewhere we can type our commands. So first thing, as I usually do when trying new commands, I just go for the help. And here you can see all the commands that is available for you to use. So all these first ones, they are Flame ones that comes out of the box when you are using the Flame Console package. So like I mentioned, you have the ls, which will list all commands. We can remove, you can use the debug command to toggle between on and off in the debug mode, pause, resume, and then we have a few, and then we start to have the custom commands, which is a command that I specifically wrote for this game. So if you take a look on the ls command, for example, it will print a list of all the instances that are running in the game right now. And then we have two informations here. So this is the object ID and then their type. This is very useful because when we want to interact with a specific command, because you see that most commands that we can use to interact with a specific or a collection of components, you can pass either a type or either an ID. So ID and type. So let's say I want to enable debug mode on all of these tiles that is Rails tile. So I can just pass, and we see that debug mode is enabled on all of those. if I type the same again, it is gone because it's, like I mentioned, a toggling. And then I'm going to show you now how you can use, right? How this can be added to your game. So like I mentioned, first thing is to add the dependence to your pub spec. Nothing fancy here. And then there is not a single way that you can use it. It's pretty much like up into you on how you want to hook this up into your game. The way that is set up on this project, and which I'm gonna show you, is which I think is one of the simplest ways, and is also the way that is explained on our documentation. If you look later there. Right, so I will just go here on my view that I have the game set up, right? So there shouldn't be nothing too fancy here. It's just a stateful editor where I have my game. And this is how I added the console to it. Using the overlays API from Flame, right? So basically, I just declare my overlay build mapper with a key console, and then I just use this Flame console view, which is a widget that is exported by the Flame console package. It should be super simple. You just pass your game, you pass your custom commands. This is not required. If you just want to use the commands that comes out of the box from Flame console, you can just omit it. But then, since I have some custom commands, that's why this is declared here, which I'm going to show in a bit. And the onClose callback, because you can close this in many ways that you want. I just remove the overlay from here. And this is just setting up the overlay, right? I still need to show, to call that overlay somehow. So I choose to show when the console when hitting the backslash key on the game. So since it's very easy to handle keyboard keys, events from a Flame game, that's just how I approached this. So basically, if it is debug mode, this is a choice too. Like I showed the screenshot from Counter-Strike, they bundle the console on the game, on the release build of the game. For me, I don't think for my game, I don't think it's necessary to have this on release, but that's why I wrap this in the debug mode. And then I simply write down a simple keyboard listener component that when the backslash key is pressed, I show the console overlay. Very, very simple. You could, and like I mentioned, this is just one of the approaches. You could, I don't know, maybe have a float action button that would show your console. You could have a combination. It would be cool to have, I don't know, Konami code, sequence of keys, so you could show the console, whatever. You are free to choose what you want to how you want to show the console or not. Cool. And now I'm going to show you one of the comments that I wrote myself. Before, let me show you it running. So my command, I call it Rails points, and it will toggle the indicators of the points of connection in each array, right? So if I do some game here, see that the card goes, and we know that each of these tiles are complemented on their own. So I wanted to have a way to be sure that the connections are correct. So I simply wrote this points. And when I execute this command, hopefully you can see this on the screens. They're a little bit small, but there are small pink boxes on all the edges of the rails that are connections. So by doing this, I can see that, so this rail is connected to this one, that is connected to this one, so on and so forth. So this command is basically just a simple command that I wrote to so I could visualize this better in a visual way, how my rail tiles are connected to each other. Cool. And then I gonna try, and now this is the trick part. I'm gonna try to write a command live to show you how simple it is to write a command when you use FlameCon. So cool. So what I want to do, so what I'm working right now is on the movement of the rail, the mine card. So what is the idea of my game, right? You need to place the mine cards next to your dwarves so they can fill in your mine card with ores, and then when it's full, it can travel out of the mine. So far I built all the code for it to execute, to run the rails, but I want to finalize this movement by being able to send the card away. But that is not working, and this is intended because I have implemented that, but when you try to move your card without the necessary cargo, right? So if it is empty, it should not move. I'm gonna show the user a message saying, hey, you need to fill your card with ore previously, but that's the idea. And since I haven't implemented the dwarves throwing up the ores, I'm gonna write a simple command that will fill all the capacity of our card, so I can be able to test the full movement before having everything set up. Cool. So again, this is open for how you want to structure. In my case, I decided to create a dev folder inside my game folder where I'm gonna place all the commands and everything. So here, I'm just gonna show you real quick, it is bigger, how that Rails point command works. So it's very, very simple. We need to create a class that extends from Flame console command. The generics, we pass the type of our game class, a brief description, and then the name of the command, which is what we will be typing. And then what is most important here is the execute method. So its signature is very simple. It should return a tuple of strings, the first one optional and the second one required, which basically is if there was an error, if the command completed successfully, this should be null, and the output, if there is any. Since my command does not have any really relevant output to show the user, I just return an empty string and null, since there is no error. And the implementation of this is very, very simple. So basically I just query on on the children of the world of my game for all the rail tiles. I get all their points of connections and basically add this rail point indicator component, which is just really a rectangle component. So one important thing to mention here is that you see that this does not couple our game with any debug logic, because this is just something that is added to our components. So if we delete this command, delete this file, we don't have to worry about refactoring anything on our real component, because there isn't any debug code there. So this is one of the things that I like about doing this type of things. We do something incremental on top of the release code. Right, so now I'm gonna create the command that I mentioned. So let me think on a name. I'm just gonna full cargo cart. And then let's just create it real quick. Maybe fill cargo cart cargo. Fill cargo cart. Yeah. So let me export it. Cool. So we need to extend our Flame console command, passing our game as the generic. I'm going to just create the overrides. There we go. Before I forget, this is just a list of my custom command, which is hook up to the UI. So I'm just gonna add it here. Oops. There we go. And now let's just put the simple descriptions, name, and everything. So fill all the cards with a placeholder cargo. There we go. I'm gonna name it fill cargo, and I'm gonna just gonna leave this empty now at first, because I'm gonna see just if our command shows in there. There we go. Awesome. If I execute it, nothing will happen because we did nothing on it. Cool. So how I'm gonna implement this? I'm gonna try something real simple. So yeah, there you go. Thank you, Copilot. That's what I want. Then I'm gonna iterate on all of them. So find the card and the cards. Then I know that my card has a max cargo, so I'm gonna just card.cargo. Actually, this is final, so this will not work. So then I'm gonna do add all. Then a list.generate. And I know that my card has a max cargo. There you go. Oops, card, not cargo. And here, I'm just gonna put any or item. Let's perform this real quick. What did I make wrong? Oh yeah, I need to be care about this. And I need to import this. There you go. So this should be everything that we need for this command. So let's see if this will work. I don't know if this will work, so bear with me. Cool. So if I try moving my card, it will not move it because the logic that I mentioned. Hopefully it worked, and now my card moved. So I was able to test the full movement of the card. Let me just put some trading comments because this line looks ugly. Well, I really don't like this on Flutter. It gets rid, the new Flutter format gets rid of our trailing commas. Well, whatever, not important for the presentation. So this is it, how you can use the Flame console. You can write your own custom comments. You can use the ones out of the box. And yeah, that's pretty much it what I had to show you all. I don't know if anybody has any questions, but if so, I'm happy to answer.
Thank you for a great presentation, Eric. And yeah, as you could see, it was about Flame console and not Flame dev extensions.
Yeah, maybe we can have a DevX extension.
And about the new formatter with the commas in the end, in the next Dart version that is bundled with the Flutter, there will be a setting that you can put in an analysis option so that it doesn't remove the trailing commas. Because yeah, I agree, it's so annoying. I don't understand why they did that.
Yeah, and since they're a bit random, like sometimes it keeps, sometimes I know it's not random. There must be a rule behind it, but sometimes it's there.
It doesn't feel consistent.
Yeah,
we had some interesting discussion here in the comments about if you could run Flame on consoles. And since you have filled a little bit with this, I guess maybe you could reply to that.
Yeah, for sure. So this is one of my dreams ever since I started work on Flame in 2018. I would love to get it to work on consoles. I had no idea how to do that on Nintendo Switch, PS5. I know some people were able to run Flutter on Nintendo Switch. I remember some POCs in the past. but I never tried it myself. What I tried a little bit was to run on Xbox, but sadly, my knowledge regarding these low levels, C++, which is required to make this work, was never enough for me to get sure. But I know it is possible. Like we just need to write up Flutter engine part for one of these platforms. So yeah, it's totally possible. We just need someone with enough knowledge and motivation to make it happen.
And here we got another good question, which I know you can answer too. What about the Steam Deck?
Yeah, that's actually is to run. I was able to run one of my games. The only challenging part, which is not that challenging, but it's something to keep in mind, not all native libraries that work on Linux will work on Steam Deck. So for example, when I ran my game the first time, it was crashing. It took me a while to understand why, but Steam Deck has a bunch of developer tools to make it easier for you to see logs and get crash reports and all that. So I realized that the game was crashing because of the audio library that the basically audio players didn't work out of the box on Steam Deck. So just to test, I completely remove audio players, and my game ran like flawless, like perfectly, just like in Linux. So it's just basically a matter of you keeping attention to our native libraries and testing it against the Steam Linux runtime, which Valve provides you. So it's totally possible.
And here we actually have a question about Flame Console. So maybe I missed it, but can Flame Console be a dev dependency? I guess it doesn't matter if Dart strips debug code during release compilation.
I believe so. I believe if you just wrap everything that requires the packaging in a debug, that kdebug mode constant, you should be able to. I just never really thought on that because I always wanted to bundle my console into the release productions, of course under like a secret code to show it, so I could debug it in release. But yeah, it should be possible. You just need to wrap your code into conditions to make sure it's not showing a release build.
And then we have a question from Luan. Given my unforgivable earlier mistake, Eric, could you briefly describe the differences of Flame Console and Flame DevTools? And when he says Flame DevTools, he means the Flutter DevTools with the Flame DevTools extension.
Exactly, yeah. So, well, first is that one is a console, the other is a DevTools, right? So the console, the interaction that we do with it is just by commands, just like a terminal, and the DevTools, we have this visual screen where you can put things and all. I guess the biggest difference for me is Flame Console is a bit more extensible, right? You can put your own commands, everything you need, while on the DevTools, you need to work with what is there. So I would say that's the biggest difference for me, feature-wise. It's easier to extend the Flame Console than on DevTools.
Yeah, great.
And also, sorry, you can have the Flame Console on an unreleased build. You can just bundle it for a game.
Yeah, and I mean, you could, like, it doesn't only have to be tools for the developer, right? It could be for power user of your application or game, right? Like,
totally.
Like it was in the old games that you showed, yeah.
Exactly.
All right, I think we should go on with the schedule now. Thanks a lot for your talk, Eric.
My pleasure.
Have a good one.
Thank you.
So before we go on with the next talk, let's just check on a slide that I forgot before. And I forgot to mention the prizes. How can I do that? So the prizes for the Game Jam is, first place, you get 2 Flutter and Friends tickets. But if it's a solo team, one of the tickets go to the second place. and you get $400 or 400 euros in one of these Visa MasterCard prepaid gift cards that you can buy pretty much anything with. And you get something that we call the Flame Care package, which has a lot of cool things in it, but it's secret what's in there. I can tell you there's at least a Flame t-shirt in there, but there are cooler things in there too. And you also get a Flutter store code, and on the Flutter store you can choose like a t-shirt or a dash, or they have some different items in there that you can choose from. And these are items you can't buy. So Dash, if you don't know it, it's Flutter's mascot. That's the little bird sitting here in the background. For the second place, it will be a 200 euro prepaid gift card, and also Flutter store codes for everyone in the team. And third place, a 100 euro Visa MasterCard prepaid gift card, and also Flutter store codes for everyone in the team. And we have a total of 30 of these codes. So if you submit something, you have a very high chance of winning one of these codes, because we will just give them out until we run out of them. I think last year we gave it out to like the 10 or 12 first teams. So if you manage to build something and submit it, you have a very high chance of winning something. Now, let's get on with the agenda. So now I'm going to introduce our own Renan to the stage. Welcome,
Hello.
Renan.
Hello.
How are you?
Good. How about you?
All good, all good.
Awesome.
Let's see. Did you have some? Did you share your screen? Yes, you did.
Yes. Well, Luan hyped it up so much, but I don't even have the slides. I just have my workspaces.
That's how good the stuff we're gonna see now is. That you don't even need any slides. I'm so hyped up for using this. Renan has been working really hard on this shader API. For, I don't know, you prepared for building this shader API probably for years now, but now we finally got it out, and I'm so happy.
Yeah, I mean, things are always evolving on Flutter, and I think it was good to wait, because now we can have great things. I just wanted to have a little bit of a story, start telling just for some small amount of minutes. I won't.
I'll leave the stage to you. I'll hide backstage.
All right. So, yes, I just wanted to tell a little bit of a story, because as Lukas said, I took some time to land this, and today this was landed, and we just have a new Flutter release, Flame release, sorry, with this new API. It was merged today, so it finished and polished. So it's I guess now it's a very small API, but very powerful. So this is totally related to this thing you're seeing on the screen right now. This is a guy I'm a fan of. And I always follow this type of people that always post those nice experiments and kind of digital art, either on Twitter or whatever social network. And this one in particular, I really like this guy, because he always posts those beautiful things. But in the end, everything you're seeing here is a result of some code and math and some concepts together. And they kind of create these very amazing effects, and those are shaders. Basically, I'm going to explain now a little bit what shaders are. But basically, this effect here, for example, from Shore, can be explained by this little code here, which is minified. This is a characteristics of this Twigo site app that allows people to write shaders in a very minified way, sometimes in a length that they can fit on a single tweet. And the end result is simply fantastic. This is one example, but shaders don't need to look like this. It's just a gimmick of this site. There's shader toy as well that allows people to write shaders in write and showcase shaders in a more complete way. Sorry. So Basically, the concept of a shader, or in this case, a fragment shader, pixel shader, can be explained by a statement that goes like, every shader is a function, and this function takes parameters, and the output is a color of a single pixel. And the GPU will take this function and run in parallel for every pixel in the part of a screen. So if you have a subsection of a screen that's running a shader, the GPU will take every pixel there, run this code with the parameters that you pass, and then it will output a color that is specified by the 4 channels, RGB and A. And so in the end, everything is just numbers. You pass numbers and it outputs numbers. So if you have lots of numbers involved, it's lots of math concepts as well. So this, like, for example, is a tutorial by IQ, which is actually the creator of this shader toy site, this guy here. And it's just a tutorial on how to create this kind of noise effects that are very useful. It's going to be useful in the example I want to show real quick. And there's several different techniques that allows people to write the most amazing things. I'm particularly a fan of this one. It's amazing. And well, naturally, when you see beautiful things and animated things, colors and everything, you wonder, well, how can I put this on an app, or especially on a game? So this is what I wanted to do. I wanted to try out shaders once I learned how this thing worked. And was at the same time that the Flutter team was introducing support for fragment shaders on Flutter apps. So I went to try. So this is one of the experiments I did back ago. It was some years now, 22. Oh my God, life goes so fast. So yeah, whatever. I was trying this out. So this is like a full functional app, an app layout that applies a fragment shader to a text, to actually a text screen, and creates this nice effect. But how about games? I mean, the natural thing when you talk about shaders in natural application, you go mostly directly to games. And when you're talking about a Flutter in games, there is only Flame. So I went to try this out. The result was this thing called Turi. It's open source. It's on this thingy here. And basically, if you go for Turi-wasm.renan.gg, you can also try this game. And this is running on Flame. I built this some years ago already, I think it was 23, in the end of 2023. So I think the Flame version is quite outdated as well. But it was nice to put through experiments with shaders, but not only one shader, but several of them with Flame. But if you look into the source code that's open, I had to build a lot of bespoke code to allow them to work quite well. One thing that I noticed that I did is that I applied these shaders only on the camera. So almost everything that you see in the screen, is an output of a shader. So if you have components like a circle or a rectangle or a sprite component, and you override that with a shader, they won't appear. So an idea that I had is that probably those shaders will take the texture of the game as an input. So yeah, those are two kinds of inputs that a shader can take: textures and numbers. Numbers can be anything based on the state of a game. It can be the particular position of something in the screen, or even the factor of opacity, or even time, So for example, here on these shaders, we have one shader for the ball, one shader for the platforms, one for the fog, and one for the reflection, and another one for the reflection of the ball in the sprites over here. So actually, these sprites of rocks to the side are the only things that are really being painted on the canvas by Flame itself, and not a fragment shader. For example, the shader of the ball takes the position of a component ball in the screen, in the viewport. But the component itself doesn't paint anything. So basically the components became a holder of state, and then I apply the shader in the camera level to render a ball, whatever it is on the screen. And also there's a little tail of the ball when it's moving. If I move to the sides, you can see. This also follows the velocity of the ball. That's also a number, a vector too, in the state. So all of this we can pass to fragment shaders. And yeah, the same thing goes for the platforms in their, let me go here, the platforms and their positions, color, and of course the fog here is an actual result of me following that tutorial on Shader Toy. The fog is basically a noise running around, so this movement of the fog is also based on time, and then we pass delta time to the fragment shader. But yeah, I had to write lots of bespoke code to allow this. Even copy some classes internally from Flame and allow me to do this. But well, we wanted to ship something with Flame to make it easy for you people to write shaders and don't have to go through all of the pain I had to go to build this. So yeah, we ship it out. It's pretty fun. So if you go for examples, Flame Engine right now, it's the examples, the most recent examples site that we have. And we have this one that is basically an example, showcase of how to use the post-processing API. We have a slide. I think this is my only slide. So yeah, this is the name of the thing. It's post-processing. Simply because we apply this in the camera level. So we let the whole camera, everything in the world render, and then the shader will take all of that as an input, and can take everything as an input to a fragment shader, and then paint everything on the screen again. And it can even be used for things that are not fragment shaders, but let's get to the code first. So yeah, this is the example right here. I'm running on a macOS version, and I'm gonna go through a little bit of codes, modify some things here and there to show you guys what changes when I mess with the code. So basically, we have the game class here, which is, of course, a Flame game. I don't want to go for that from scratch, extending game. I don't know. I think we should do something on Discord, asking people like how many of you extend Flame game and how many of you extend game directly. I never extended game directly, but I know some folks that did. Yeah, so we have some different places we put the post processes, but a post process will look something like this. All right, so we have the constructor of the game, and there we set up the camera. The camera has now a new property called post process that you can add, that you can set to something, or even if you want to remove post processes, which I think I'm gonna do now. I want to mess with things. I'm feeling nasty. I'm gonna mess. Oof. Let me see if I remove the post processes and restart this thingy. Nice. I removed the post processes that we have in the camera level, but we also have one, for example, as an example, in a component level that's called ball glow, that I'm gonna remove here. Just still feeling nasty. Let's go. And now, something happened. Yeah, it shouldn't. I messed it too much. But yeah, so we have all of these post processes happening. I'm going to explain a little bit what's going on here. So, of course, I copied most of this code from Turi, but I added this to comply with the new post-processing API that's within Flame. So there's not that much of bespoke code anymore. Just the things necessary to run the demonstration, and all of them is, of course, The only thing that is actually moving here in the world of Flame is the component called the ball. All right, it's different from ball glow. The ball is this very, very nice component here. It's just a position component and has, let me set the debug mode. Debug mode. Whoops. Oh, yeah, this is position component.
Add a get.
Oh, yeah, I forgot how to code in Dart, by the way. Oops. I totally forgot how Dart looks like after doing this for so many years in my life. So yeah, there's a component right here, right? And it has a 0 of width, 0 of height. We just care about its position, right? And it has some update shenanigans here. This is basically gravity based on velocity. So yeah, it's our everyday jumping logic on update. And we have another component called ground. I'm gonna copy this so I don't expose anymore that I don't know anything about Dart and Flame and Flutter and the coding and programming. Let me see here. Good. Oh, where's the ground? Oh yeah, the fragment shader is actually. The post process is actually overwriting everything that's being painted. Yikes. Let me just restart. Oh, here we go. So this is the ground. Basically, it's a series of rectangles there that I have collision detection with the ball. Yeah, so it's pretty interesting. And when there's when the collision happens, we call this method jump that inverts the velocity of the ball. So the ball, if it's falling, boom, go up, basically. And also updates the camera, but we don't care about camera in this demonstration. We don't care about the camera position, at least in this demonstration. Here we go. So this is pretty much how it goes. But the first post process that we have, and remove lovely, and the ground, lovely, and let me restart. Cool. So the post process is taking some parameters, and I can go to it. It's a ball glow. Ball glow is a post process component. As I said, this is a post process that we didn't add to the camera. There are two ways you can use post processes in the components level or in the camera. The camera are ideal for shaders that will need a holistic vision of whatever's going on a viewport. So it will be the last thing rendered on top of the camera. So basically, we render the entire world, and then after that, pass the results of that to post processes. In this case here, we have a post process component that does exactly the same thing, but to its children. So this is ideal for localized shaders or specific parts. Here, we're applying to the ball. Of course, this shader has the size of the entire screen, so it would be probably better off on the camera level. But I decided, as an example, to use this one as an example of a component. So yeah, the component holds a reference to the word and pass to internal post process. And we also update the size and position within the game. So basically, it keeps the same position as the camera and keeps the same size as the camera viewport, which is game.size is the same thing. So this is the component, and then we have the post process that it receives as parameter. Here I'm passing inline. It's a ball glow post process. Post process is not a component. It's something that we can add to a camera or to a post process component, but it's its own definition of what a post process is. And this definition is pretty much this function. So this function receives a canvas and the size. The size is either it's the size that your shader should assume in the screen from the offset 0, of course. So when you add to a camera, it's the size of the camera. When you add to a component, it's the size of the component. If you specifically set the size of the post-process component, which I do here. But if you don't, it will assume the size of the bounding boxes of its children. So if you have a sprites component as a children, for example, and the sprites component has a 200 by 200 pixels of size, we don't need to specifically pass the size to this component. You assume the size of its children. And then inside of it, we have two nice functions that we can call to render everything that's called a subtree of this position component. The subtree is basically everything that this post-process is processing. So on a camera, the subtree of a post-process is the whole word. It's a subtree of the camera with a word. But when this is added to a post-process component, the subtree is the subtree of that component, so the children and all of the descendants. So to render the subtree, you can call either render subtree, and we pass the same canvas. So basically, this will just execute the rendering of the subtree, and whatever the children paint, it will go unmodified to the canvas. This is great for a pass-through post-process in which you don't care what your children is painting. You just want to add something on top or below. If you want to do below, then you add you call render subtree in the end of the function, not in the beginning. So if you put here, everything will paint to be below whatever all the children are painting. If you call on top, you paint on top. This is useful for effects like the fog that we saw on this example. The fog doesn't really care of what's below. It just paints some random noise on top of it and moves around. So yeah, this is pretty valid. Or you see these little green things flying in the background. So this is also its own thing, you know. It doesn't need to know what's being painted by other post processes or by the game. It just needs to paint something there in the background. So it's pretty useful for that. But some other shaders, they may require you to rasterize a subtree. So this is the most important, the big importance thing here. For example, the shader here that paints the water, that will have reflection. To create the effect of reflection, a shader needs to receive the rasterized version of everything that was painted before, and invert the pixels and all of its logic to create a reflection. So we need an image as a parameter of a shader. How you do that? Well, here we can have something that's another method that's called rasterize subtree. So basically this will render the subtree, but it executes some special things internally. We create a picture recorder, create a canvas, render the subtree with that new canvas with the picture recorder, and the picture recorder, we will create a picture and then convert to a UI.image object. And this can be passed to the fragment shader. Fragment shader do its things, its transformations, and then paint the result on the screen with logic like this, right? I'm not going to go deep on all of this logic of this specific shader, but here is, important part is here is where we are passing the number parameters. So in this case, what we care about this. The first thing we pass is the size in which the shader will assume, and this will be used internally by the fragment shader code. The position of the ball here is UV ball because it's the normalized position of the ball related to the space in which the shader is being applied. So basically, if the ball is in the middle of the screen, then the UV ball is be 0.5, 0.5. It's in the bottom corner, so it will be 1.0, 1.0, and yeah, you know what normalize means. We have gamma that basically controls the brightness of the ball. I think you can tweak this. I think 1.0 is a lot. Didn't do anything. Let me see. by 7. Oh yeah, here we go. 1.8. Let's go. 9.8. Phew, this is very bright. And yeah, we can pass these kind of things. And imagine in the game, if the ball hits a special part of the screen, a special platform, for example, and that special platform makes the ball glow a lot and even change its colors or things like that. You can control this state on Flame now. Basically, what's what we have here. If you update this value, you can even apply effects to these values, and then the result will be immediately felt on a post process. And there's also the radius of the ball, and yeah, all of the different types of parameters. Let's see how the shader, the actual shader code looks like here. So yeah, we have some shaders here. There is the ball shader. So those are the parameters we're passing. Okay, for this one specifically, we are not receiving any bitmap. We don't need to rasterize the subtree to render the ball. So we're not receiving any textures here. We're just receiving numbers. And it's the same ones I just explained. The position of the ball, that's called light source here. The velocity of the ball, yeah, the velocity of the ball is used to create this little tail. I just explained that. The radius of the ball and also the gamma thing that I was messing about is being received here. And then I have the shader codes that will paint this ball with lots of fun logic that I wrote this some years ago, and I have no idea how they work now. They look pretty nice though, but they are working, and I'm not gonna mess with it now. But one thing that I know is that this is the color of the ball. No, it's not. This is the trace. Oh yeah, this is the color of the ball. Let me see if I change this color here. Ooh, it's blue. Ah, nice. Oh, it's look way prettier blue. Oh, I think I'm gonna keep this and update on the Flame repository. Just yeah, and we could also control this from the art side, the Flame side, just by maybe substitute this with another uniform with U color, and then you're gonna add this thing here. But I'm not gonna go that deep on live coding right now. I thought that was going to be pretty fast, and I'm kind of extending my time. But yeah, so this is one of them, one of the post processes. We have some others. We have the fog, which is pretty nice. The fireflies in the background. All of this is as an example. So if you go for example, examples.flame-engine.org, and you click on this little code thing here, it will actually go to the source code of this demonstration. And the interesting part of this is that it's updated and it's using the latest version of Flame. Yep. So I guess that's pretty much. Oh yeah, I removed the post processes from the camera, and then I've added back again. So we have the game. I go to the game, and then I can stop doing this. Oh yeah. Here we go. Oh, come on. Load. Oh yeah, I have to reload. Here we go. Oh, it's still blue. Nice. Probably I have to update the fog as well. And ooh, this is nice. So what's this? This is not one post process, it's several post process. Yes, we have an idea of pipeline of post process. So we have this idea that well a post process paints this subtree of things and then creates its effects, or it creates effects and then paints the subtree. But what if you want to combine different post processes? This is what we are doing here. We have the ball that's separated, it's a component, so it's inside of the word, and it's part of a subtree of a camera. So we're adding post process to the camera. Naturally, the ball will be treated just like as a component of the game. But we have this sequence of different processes to create this effect. So here we have a post process group, which is basically like it's like a widget on Flame that receives lots of children, like a column. It's like a multi-children widget, but it's like a post process that receives other post processes, and the same goes for post process sequential group. There are two different types of groups of post processes that they themselves are post processes, but they're just used to group the ones that you will actually write. The sequential one works like this: every post process in this list will have as subtree the previous post process plus the subtree of either the camera or the component. So Firefly is receiving as a subtree everything on the game, and then it's painting its thing. And then we have Water that is receiving the Firefly that also had the whole word as an input. And then we have this pipeline of post processes. So that's why we can see fireflies in the water, because the water is receiving the fireflies and the whole word as input, And then the water post process is actually one that is rasterizing a subtree, and it's passing as an image sampler. So this is how we pass an image to a shader. And then we have it's called ground GLSL. Here we go. Something happened. Yes, here. Ground frag. Here we go. This is the shader, and it's receiving the game canvas, all right, as a parameter, and we are sampling this via the texture function. A detailed tutorial and documentation how to use shaders on Flutter, that in which Flame is based on, can be found in the official documentations of Flutter, with some more details on how to actually write your own shaders or import some either from Shader Toy or from other open source projects. And this is the one that's actually creating the reflection in the water. And yeah, it's pretty much, this is the logic. I think this is kind of custom made. I think I did it myself some years ago, and I tweaked it a little bit to this example. So yeah, this is how this is reflecting not only the ball, but also the fireflies, that is itself a result of this nice post process that we have. There's also in the end, there's the foreground fog, which is basically this fog that's moving about. It's on. Let's go back to the pipeline. It's outside on this group that's called post process group. It's not sequential. So this one, unlike the sequential, we run every post process here in parallel. They're not actually in parallel in codes, but philosophically speaking, the subtree of all of them is the same. It's the one that's received, in this case, it's the camera, the whole camera word. But then you can nest groups and everything. My only thing that I will advise people is not to run this function a lot. Rasterize those processes. This is kind of expensive, and you're running on every frame. So try not to do that a lot and create a pipeline of 30 shaders or something like that, with one taking the output of the other. It's quite costly, and I tried to push the boundaries of this, and we had some nasty crashes. So don't overdo it. All right, and also always release mode is more performance than debug mode. So maybe if it looks terrible or on debug modes, and you try to run release, it looks maybe it'll be looking fine. So put that in consideration as well. And I think this is a wrap. I'm sorry for the time.
That was awesome. Great job. I am looking forward to using this API so much. It's almost good that I'm not in the game jam, because then I can try to tinker with this on my own game, right? I think we'll take we have a Q&A with all of the Flame team in the end, and I think if anyone has any shader questions, let's take those ones in the end, and we'll clear the stage for the next speaker. Thanks a lot, Tanal. So the next speaker is no one less than Jonah. He has almost 2,500 commits on the Flutter repository, which is the most anyone has except for bots. And I guess a lot of those commits are actually squashed too, so it's even more ones. Welcome on the stage, Jonah. Hello.
Hello. Can you hear me?
Yes.
Awesome.
It even worked without the tech check before. That's great.
Yay. Thank you for having me. I don't have a lot, but I have some stuff to show. So
yeah, that's great. I think some people will have some questions in the end too, probably. Yeah. So it'll be like, yeah, these ones are always super laid back. You know, you just saw Renan live coding. Yes, yeah.
That's good, because like I said,
it's all for
I'm
fun.
not super well prepared.
Yeah, no problem. I'll leave the stage for you.
Yeah, let me go ahead and turn off the infinite loop here. Get my windows back up. Okay, so I'm presenting a quick Impeller overview, mostly focused on like sprites. And so I have I'm mirroring this. It's a Galaxy A05, which is a budget phone, just for reference when we talk about performance. Yeah, so like, what is Impeller if you don't know? If you look at the Flutter architecture diagram, Impeller is the thing that replaces Skia in this little block here. This is not to scale in terms of like lines of code, but that's what it is. The background on why we did Impeller was primarily to remove shader compilation jank on iOS. But we've also made it default on Android. Why? Well, we sort of expected average frame times to slow down due to Impeller on iOS, but like worse frame times would get better. But eventually we were also able to improve average frame times. Eventually improved the performance of arbitrary path and clips, removed the ill-fated raster cache, and then it gave us an opportunity to do Vulkan on Android, which provides a decent speed up on newer devices. So I don't want to bore you with like slides. So we're just going to go into some code. And what I'm really looking at here is what's the performance like of sort of like sprite-based rendering. So let me go ahead and make sure I've got this all set up right. Yeah. Now we get to wait while this builds. Probably could have like queued it up, but I didn't do that. So I guess I'll show you the sprites I made. This is my dash sprite. Can't see that. It's my dash ball. Oops. Ooh, yeah, just wait. There we go. Okay. So I'm drawing some sprites here. Let's take a look. I'm going to update the positions every frame. Actually, that needs to be a restart. And then I'm going to show the performance overlay. That's probably not legible on the stream. You'll have to look at like the relative height of the balloonist, but this is pretty quick. And I want to just look real quick at our game painter here. This isn't using Flame. This is like the simplest custom painter, where we're just calling draw image in a loop. So let's like kick it up until it slows down. By the way, if you didn't know, 1,000. You can do this now. Put separators in it. Okay, so we got 1,000 sprites. All right, we're gonna kick it up to 5,000 sprites. This is 20 milliseconds a frame. We're gonna kick it up to 10,000 sprites. That is starting to slow down now. Okay, if I do 100,000, is it going to blend or is it going to just... Yeah. This is still almost playable. I don't know if you played Vampire Survivors, but it basically looks like this after a while. So go back down to a reasonable number like 1,000. So I want to do a quick side-by-side here. This is about like 10 milliseconds. I want to show you Skia just as a reference. No enable impeller. I promise I have more than this, but not much more. So now we're going to wait again. It should be mostly built at this point. I do probably need to open a window with like chat so I can see if someone is yelling at me that my mic isn't working. But unfortunately, I only have one monitor, so yes. Okay. Let's look at Skia. It's about the same. That's not really that surprising because there's really not that much in drawing a sprite. We're going to go over what drawing a sprite's like in a second. But let's kick it up to 10,000. So this really starts to slow down. I would say maybe a little bit sooner, but it's pretty close. So now I want to show you a trick. But before I do that, I'm going to actually no. Okay, so we're in Skia now, so don't forget. So the trick is Draw Atlas lets you combine multiple sprite draws into a single draw command. And this doesn't really speed up things on like the GPU side of the work, but in terms of like when you call canvas.draw whatever, we're recording that in some format and then we need to play it back and there's bookkeeping. It does speed up that. So we're going to switch over to our called the Atlas Game Painter. If you notice, Skia gets a lot faster because of course it's doing this work. This is like 12. We're going to switch back to Impeller. I'll make you guys wait again. Boo, boo, boo. Check the chat. Yep. Volume still works. How many sprites am I drawing with Atlas? 5,000. Do, 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 do. Do, 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 do. I will strategically drink some water. This is the last time I'm going to switch back to Skia, so we can just stay in the app. Yeah, it's a little bit faster. So let's try some of the numbers. Let's kick it up to 10,000. And now it's starting to slow down. We're at like 20 milliseconds. So if you haven't looked too closely at it, Draw Atlas, if you notice, it's a little bit odd. We have our Atlas parameter. You can use it to draw the same sprite over again. In which case your sampling rectangle is just going to be the whole sprite. Your RS transform lets you scale and position it. A lot of people don't know what these settings do, so you can provide this list of colors. And then this blend mode is not the paint's blend mode. Paint's blend mode is source over. This blend mode says is if you provide a list of colors, how do I blend those colors with the sprites? You can actually use it to add tinting to sprites. So I can go color. Just do color. FF. FF. I mean, this is, I'm not going to call it free, but it's pretty cheap. And of course, if this is null, then this blend mode doesn't do anything. Okay, let's go back to a regular level sprites. Now, of course, there's other things you can do with draws, and this was a bug that came up a couple weeks ago where, hey, what if I want to what if I'm not using Draw Atlas and I still want to like add some color into my sprites? Well, the natural way to do this was like a color filter. So you'd say like, oh, well, this blend is very similar to this blend. I think you'd have to look at the parameters, make sure you know which one is source and dist. But if you run this on stable, if you run this on stable, you'll probably crash and run out of memory. Whereas with here, you won't, because I fixed a bug. Because like what this technically implies is a save layer, so it's equivalent to doing like draw my thing, or save layer, draw thing, restore, which is basically the same as doing something like the post-processing API. So it can be expensive, but it's also very easy to optimize because like this draws an image, the filter takes an image, so you can just sort of plug them into each other on the back end. You can't do that with every kind of shader. So if you do an image filter, like a blur, blurs are 2 passes, so we can't collapse that. I think if I hot reload now, my phone will actually run out of memory and crash. So let's turn this number down to just do like 50. So it's going to be quite a bit slower. You say like, Jonah, can the backend detect that like the sprites are the same and you've already computed a blur? And it's like, yeah, we could, but that probably doesn't happen that often. There are tricks for this, which is essentially just create a new sprite that's already been blurred. So you can do that. You can just create a picture recorder at any point in time, create a canvas, draw your image, apply the image filter blur, call to image sync, and now this is an already blurred image that you can draw everywhere. So let's switch to that. That is quite a bit faster, drawing substantially more blurred dashes. And of course, like something else we want to do with Impeller is make like path drawing faster. And path drawing wasn't always slow as Kia, but it had some unfortunate performance edge cases. Generally a lot happier with like the path drawing we have now. So, if you have something that's a path, you don't need to convert it to a sprite. And the cool thing about solid color paths is if you do a color filter on it, we don't have to do a save layer either because we just change the color that you've used to render the sprite with. So yeah. Let me see, where was I here? So sprite performance. Quick summary: Draw Atlas, big speed up, blend parameters. You can use them for coloring sprites. If you're using Draw Image or Draw Image Direct, like you don't really need to put all of your sprites into an atlas. It doesn't really help that much as long as you have fewer than like 1 million sprites. Non-color filter effects still use save layers, so you use them sparingly or cache. And then if you're trying to do like, oh, but I have this sprite and I want to dynamically color it, and I can't do it in a way that fits nicely with the color filters. Well, like use a shader for that. It's okay. Like all of this is shaders, and we're actually going to look at that real quick. So if you're curious to look into like the Impeller code base, we're all in one repo now. So if you go Flutter engine source Flutter Impeller, start at like Canvas. You say like, oh, draw image direct. Yeah, this is C++, but code is code, right? So I mean, this is it. This is where the magic happens. It's not really that complicated because again, drawing a sprite is, well, there's a rectangle and you fill in texture. You can even go, if you follow the code all the way, you can find something called the texture contents, and then eventually you'll find the texture fill.frag, which is the shader. And you can see like it's a very complex shader. It samples the texture and then that's it. Has some alpha in there. So yeah, you're like, well, Jonah, I don't work on the Flutter team. How do I understand the performance of like the raster thread if I don't already know this? And that is what you use CPU profiling for. So on iOS, this should just work. On Android, you need to add this to your build.gradle. So this is just a Flutter template example app. Packaging options, do not strip. Don't ship with this because your APK will get huge. But what this does is it leaves symbols in the binary. And then this is fairly easy to do with Android Studio. So quickly, let's switch back. I'm losing track of my windows here. Let us switch back to the first painter here. Let's make this a reasonable number, like 1,000. And we're going to turn off the performance overlay because, of course, if you measure the CPU time, you'll see performance overlay time in there, which isn't really what you want. So yeah, in Android Studio, depending on what version of you have, there's like a little profiler. Call stack sample. Find your process name. Go away. It's going to yell at you, but don't record more than like a few seconds. All right, this will give you all your threads. You are looking for the raster thread, which is here 1.raster. And then flame chart gives you a, oops, try that again. Flame chart gives you a sort of breakdown about what's going on. If you haven't seen flame charts before, you can think of this as like, this is an aggregation of all the function calls. So the way that works is every period of time, like say like 100 times a second or 1,000 times a second, the profiler captures the stack, every function that's on the stack, and then sort of saves it and then aggregates together. So this tells you sort of the relative time spent. And there's, wall clock time and thread time, and we'll look at thread time because we don't care about waiting, for waiting for the next frame. And this doesn't really tell you a lot because again, this is so simple. All this libgles mali, fun fact, like this is what the Vulkan driver is called on this phone. I don't know why. I assume they just couldn't rename the binary because it was too hard. So like, okay, we call draw, and that's what most of this time is, and then the rest of it is all very fast. Occasionally you'll run this and you'll see something that's like, whoa, why is that taking so long? Although that's very hard to do if you don't kind of work on it. But yeah, not a lot in here. You can actually also look at other threads, and you can't look at Dart code on the UI thread, but you can look at the native code that Dart calls. And there's actually something interesting in this trace. If we look at the flame chart of the UI thread, which will always be like the main thread now, you see like, oh, okay, let's see init. I don't know what that is, but I see canvas.drawImage. And actually, if you look, it looks like the slowest thing in here is calling drawImage. And the reason it's slow is because when we pass a paint from Dart to the native side, we have to like copy these bytes out of the Dart heap. And for reasons that I don't fully understand, this is actually extremely slow, and I want to fix this. And I noticed this, like, actually when I was preparing for this presentation. Yeah. I suspect because when you get data out of the Dart heap, you have to tell Dart's GC not to GC while you're reading out of it. But I don't fully know. Yeah, let's go ahead and close this. Go away, Android Studio. I don't want to see you again. Booted. Cool. And yeah, so sprites are a little bit faster, we saw. Mostly it's faster because of things we don't do. Like we don't have any pointless raster caching. The raster cache was like, it was not ever effective for games like, for like games, because everything is constantly changing anyway, so there's nothing to cache. This may change, but we don't currently attempt to like batch things up. So there's like a one draw call to one draw call, because we found that like the native APIs are actually fairly fast. So trying to add your own caching on top of it. If you do it wrong, you may end up just slowing things down. We don't do a lot of complex scene analysis. We sort of like when we record the commands, there's like a structure that the Dart and the native side use to communicate to. And then once the native side gets the command, it goes right into the driver, which is pretty fast. And then we use hardware anti-aliasing, which is good enough for most cases. And yeah, questions. The big question I have is like, is there a way that we can improve on the Draw Atlas API so that it's more usable? I'm not really sure. Or like, do we just need to find ways to make Draw Image Rect faster? Are those even the bottlenecks? Of course, you know, if you're bottlenecked on like GPU work, you're seeing a lot of like back pressure. Then obviously changing the exact structure of the APIs doesn't really help. But yeah, in conclusion, sprites are pretty fast. You can do a lot of them. Use a profiler. I didn't cover GPU profiling because unfortunately on Android, if you want to do GPU profiling, you have to use vendor-specific tools, and they all, I don't want to say they're all bad, but some of them are kind of bad. And they're sort of hard to make sense of if you're not, they're hard for me to make sense of. But yeah, there's probably a number of sprites that's like a limit. So yeah, questions, comments, concerns. If you have strong thoughts on Draw Atlas, like please reach out to me because I don't work on games primarily, so I don't really know what to do there. Yeah.
Thanks for a great talk. That was very interesting. The bug you were talking about, that was the one we reported and you fixed really quickly, right?
Yeah.
That was super nice to see that just
well, we actually had that. We had that optimization already, but it only applied if the source and destination were the same size. So if you're drawing an entire image, but I think what Flame is doing, which is totally differently, is you're drawing a smaller region from an atlas.
Yeah, in that case, I think it was like that. Yeah.
And we just never seen that, so we didn't bother to like optimize that case.
Yeah. I guess you would. It would be very rare that you would do that a lot in normal apps. It would be kind of weird app, but in games,
it's fine. Like I said, it's very easy to fix. It wasn't hard at all. It's just like, oh, change this line.
I was thinking about the code you had there. I wonder if you would have moved out the paint object out of the tight loop, if it would have been more efficient. No.
So the way this API works, well, actually any of them. Let me just pick the first one. Is that paint is mutable, right?
Mm-hmm.
So every time you call draw image, you don't know if it's been mutated or not. You could track it, but like in the simple case, you don't know if it's been mutated or not. So you still have to copy it over.
Right. For the copying over, indeed. But I don't know. For some types of objects, we have seen that, like yes, having them created in the tight loop brings down the performance.
Yeah, if you look at like the way I did the image filter or like the color filter, I created out here because like each time, if you did this would be slower. These aren't like paint itself is not a oops. I'm not seeing the screen. Oops, I stopped hitting the share screen button. Window. Sure.
Let's see. Let me bring it in.
There we go. Okay. Right. So what I was saying is like, yeah. So every time you call draw image, like we have to copy the paint because it's mutable. We don't do that for paths. We have like logic that if you don't mutate a path, we use the previous one. For something like this, like it would be good to hoist it out. And an image filter isn't super expensive to create, but like there's no reason to create 1,000 of them.
Yeah.
Same with color filters. So it does make a difference sometimes. It won't help this case. I've seen some apps where they're like very careful to only create like a single paint for each kind of draw, and then be really like sort of cautious and like I don't think you really need to do that. But yeah, if you're gonna look over something 1,000 times, then probably don't. and do it 1,000 extra times. In all cases, like moderation and profiling will get you there.
Yeah, exactly. Yeah, maybe it would have some effect on the GC if you have that a lot too. I don't know.
Yeah, a lot of the Dart UI objects are sort of odd because the Dart object itself is very small, but each of them have like a native object pointing to it. Sort of weird, like it's not. Yeah, there's like two objects, right? There's two paints, there's two paths. Things like rectangles we just copy through because it's 4 numbers. And so we've had some problems where the Dart GC sees an object and it's like, oh, that's a tiny object. I'm not going to bother to GC that. But that Dart object has a pointer to a native object, and that native object has a lot of pointers to a bunch of very expensive stuff. And we've tried a few approaches to like tell the Dart GC about the size of the native object so it'll have better heuristics. And they basically all didn't work, which is why a couple years ago we started adding dispose APIs on certain things like picture. Like a picture has a dispose.
Right.
And the reason why is because, well, picture is a pointer to this native data structure that's holding all these like draw calls. And so it can get actually quite big. And it can hold on to other objects, like it can hold on to images and keep them alive. But the Dart GC doesn't know how big that object is. It just sees this little, just this almost empty picture object, and it's like, I'll get to it when I get to it. So those can end up sticking around longer, which is why we added disposal. Of course, the other side of that is like if you call dispose on a picture and then use it, it's going to
of course.
Yeah,
so that's on the developer. Should we take some questions from the audience here? Let's see. From Renan, is there a limit of uniforms we can pass to a frag shader on Impeller?
Yes.
I think I think it was a rhetorical question from his end.
Yes, there is a limit. There is a limit. On iOS simulators, it's pretty low. It's not exposed. We need to like expose something. I don't know what it is at compile time. It has to be a runtime check. Because it varies. I would say if you're getting into the kilobytes, you're probably going to have a problem. You could do tricks like let me see. Can I get to that code from here? Thinking. What's it called? What's the ink ripple? Ink ripple. Packages, Flutter material, ink ripple, Dart. Yeah, there's a limit. I don't know what it is. Please file a feature request, and we'll look at figuring a way to expose it. But it has to be like a runtime thing. I think we could probably advise on there's both a maximum size and a maximum uniform count. They're two different values. So you can create really big single uniforms with like very large arrays, and you can obviously like blow your uniform count by just having a bunch of floats. In the case where you just have a bunch of floats, like you pack them into a vec4. Yeah, please follow bugs. Fun fact, like everything's always a vec4. If you have a float uniform, that's actually a vec4 that is just ignoring the other, Y, Z, and W for you. So it's no cost to pack values into it.
Makes sense. Let's see here. Was this a question? Yeah, I actually wonder why there's no destructors in Dart. I guess you're not from the Dart team, but maybe you have.
I mean, the answer is generally that because it's a GC language, you can't rely on GC to happen at a predictable time, which makes destructors kind of useless compared to like C++ when they always run when things go out of scope.
Yeah,
there are finalizers now. So like if you have an object that like when it's destroyed, you need to destroy another object, you can do that correctly now. But yeah, the destructors don't play nicely with GC. because, in C++, you'll do something like, write some example code. You'll have like, my struct foo, and then you create your foo, and then do something, and then, the structure runs here. Like, it runs exactly at that point, and so you can make guarantees that, like, maybe this foo is holding on to like a file. Similar, like, and Python has like the width, like width resource equals blah, and then at the end of it, it runs the cleanup. But if you rely on the GC to do that, then you can't, like, this will be destructed at some point in time in the future. You don't want to run the GC constantly. So I think probably a Dart person can give you a more technical answer, but the short answer is that it doesn't play nicely with GC.
Maybe we'll ask Slava on Flutter and Friends.
Slava would be the person to talk to.
Yeah.
I probably butchered the explanation.
All right, let's see. Do we have some more questions here? Doesn't seem like it. Okay, well, thanks a lot for joining us. It was a pleasure to have you here.
No problem. Thanks for inviting me.
Yeah. Have a good, I guess it's day at your place since evening here.
It is 1:30 p.m. So
Yeah.
I'm probably going to get up and go for a walk at this point because I'm absolutely falling asleep.
Yeah, sounds like a good idea. Have a good one.
Thank you.
Ciao.
See y'all.
All right, so that was Jonah. That was very interesting. Now it is actually time for the Flame Q&A. We'll see how many of us are left here. And for the ones that have forgotten or that have joined late in the stream, the theme for the Flame Game Jam is the Space Race. And we have something called diversifiers, where you choose one of them, and you can use more than one, but write in your submission which one you have chosen that we should look at. And the diversifiers are shaders, immersive sounds, and branching storylines. But yeah, now it's time for Q&As. Now you can ask any Flame questions that you want. Or, well, it doesn't have to be Flame questions. You can ask whatever you want. Welcome back, folks. I think Jochum went for a nap because he wasn't feeling too great. No, it was Renan, but he's here.
Yeah, I'm not feeling really great.
Okay, but you're fighting through the stream anyways. Yeah. Okay, let's see. Yeah, if you have questions, just post them in the chat. And I know that the YouTube stream is maybe like 20 seconds after us talking here, so I guess we'll have to wait for a bit if anyone actually have questions. I see Luan is sitting there with his dash. I can tell you an anecdote from the first time I saw Dash, which was in a call with Renan and Luan and Erick. And I think, Erick, you didn't have a Dash at that time either. But Renan and Luan were sitting with them like this. And I was like, why are they sitting and playing with Pokemon? Because I didn't know what Dash was. And I didn't know them very well either.
I had this one
fun.
too. I don't know who will recognize this. But...
Is that from your game? The Painter game?
No.
It kind of looks like it.
No, it's from A-Spray.
My Dash is gangster.
Oh, yeah.
Nice. Now we actually got some
before.
questions now. So let's move over to those ones instead of...
Let's be serious then.
So from Seus, no idea how that's pronounced. For Renan, he's curious about the general performance impact of using shaders on Flame objects.
Oh, yeah. Mostly can see for yourself. We see some impacts on the web when it's not using WASM. So if you're using, if you're targeting the web, if you have problems with performance, try compiling to WASM. and things are significantly faster from what I could test. Most of it's really hard to hit a performance problem when we're running one shader on per frame, but if you're running several, like I am, you may start facing some problems. But be careful. The most try to do math things that could be inside of the shader. Could be inside of the shader. Try to do inside of the shader. Don't do that on the canvas parts. But yeah, in general, it looks really good from what I could test.
Interesting. I guess we will now when this is released into the Flame API, it will get even more battle tested.
Yeah, for sure.
So we'll see where the limits lay.
Crazy stuff.
Yeah. I hope a lot of people will use it for the game. Yeah, it will be very cool to see.
Mm-hmm.
Yeah, any more questions? No, just Roa talking about. So to give people some context, we built some hats out of dashes for Flutter and Friends last year, and some people thought they were really scary.
Yeah, people took the insides, the guts of dashes, and made them as hat.
It's beautiful.
Just like some tribes around the world did with their enemies.
Except Dash is our best friend. And Roa says, can't wait to try that. I'm sure she's talking about the Dash hat and not the shaders.
For sure. Please remove any dashes from her house.
Yeah, so if there are no more questions, I think we'll get on with the Flame Game Jam. And if you haven't signed up on itch.io yet, make sure to do that. And make sure to join our Discord server too, where there is a channel called Flame Game Jam, where all of the fun stuff is happening. And if you're looking for a team, there are some other people looking for teams in there too. So yeah, check that out. And thank you all for joining us today. It was great fun.
Super fun.
Yeah.
There will be an end stream in 9 days, I think. It will be a lot shorter than this one. So from all of us at the Flame team to all of the viewers, see you later.